Hello everyone, my name is Hamid Iravani. I am a Transportation Planning Director and also a member of Fellows Board of Director based in Dubai, Parsons. As part of the Fellows Program, I've been directing development of a multi-criteria decision analysis tool. Specifically, this program can conduct alternative analysis and evaluation and could be very useful for the work and the studies you do. It's not discipline sensitive program. That means it can be used for transportation planning problems, environmental planning, various engineering studies, finance, talent management, as long as you have set of alternatives and you can define alternative evaluation criteria. This program can be used and applied. This video tutorial is really a supplement to the user's guide for the program, and in order to get the best out of it and learn it more, it's good that you do both. You watch the tutorial video and also review the user's guide. The program applies a very systematic and scientific process using different methodologies, and given the algorithms used and applied are streamlined by the program, then the process can be error-free and you can conduct many alternatives analysis in a much faster time, do many what-if analysis, develop many scenarios, and conduct a real systematic alternative evaluation process. So with that, let's start and see how the program works. Okay, the very first question we need to ask is why even alternative evaluation requires more complex methodologies. Why not just a simple way? Yes, let's say if we had a simple example like the one you see, sure, we don't need any complex methodology. In this example, very simplistic. We have 4 alternatives. These are candidate employees, and we want to see who to hire, who is the most preferred candidate. So the criteria we have here is experience, presentation, and recommendation we have received. And all the numbers and all the values are in rating scale. Basically from rate 1 to rate 5, 1 being very bad and 5 being very good. So they're all consistent, they're all rating scale. At the same time, rating is subjective, isn't it? Because, this is the matter of our opinion. Whereas experience, instead of rating how good, how bad is their experience, could be number of years, the actual number of years. But in any case, here, all the values are in the same scale, they're all rates. You simply add up these values. They can be add up because they all are in same unit of measurement. And looks like Mary is the first winner here. She got 14, and that's the most preferred alternative, and appears Jack is the least favorable, and that's it. So it's a very simple methodology, can be used. Now, why not always like this? I'll explain. Okay, so these are some of the complexities or characteristics that the problem we are trying to solve and the criteria involves that, doesn't really require any simplistic methodology to be applied and requires more complex mathematical formulas in order to solve the problem. So, many of these problems that we deal with and evaluation that we want to do, that are multi-criteria. Of course, even the previous example, that simple example, was multi-criteria. Remember, it was experience, education, and recommendation. So that's common generally with most of the problems we are trying to solve. There are multi criteria that are involved, and we need to evaluate based on all those criteria. Of course, if it was one criteria, then simplistically you just see whichever is the highest or lowest depending on the criteria, and bingo, that was your answer. But you didn't even need to sum it. But that's common, as I said, multi-criteria. But another thing is the objectives are contradictory. I'm going to use lots of transportation planning problem in order to cross my message, since I'm a transportation planner. But it's applicable for many other problems and majors and fields. When I'm saying contradictory objective, for instance, when it comes to cost as a criteria, you need to reduce the cost. That's your objective, to reduce the cost. And let's say another criteria is public transit ridership. We want to encourage using public transit, let's say in a city, but that one you need to increase the ridership, increase number of passengers using public transit. So as you saw, one of them is to increase public transit ridership, and cost you need to decrease. So you cannot add them up simply, because one of them goes up and gets better, one of them goes down and gets better. So that's one of the complexity. You just cannot simply add them up. Then another thing, in many cases, evaluation criteria are not always measurable. They are not quantifiable. For instance, in transportation planning, the criteria is that we want to make the traffic better. Traffic is a criteria, but how do you measure it? That's why we develop what's known as measurement of effectiveness, and sometimes each criteria could have several MOEs, or measurement of effectiveness. So criteria becomes traffic or auto traffic, let's say, and measurement of effectiveness could be travel time, that's measurable, vehicle kilometer traveled, let's say, speed, and so on, which represent the traffic in a measurable and quantifiable manner. Then another complexity, when measurable, many times they have different units of measurement. In the previous example, you saw all of them were rates, but when it comes to cost, it's in dollars, and maybe it's in thousands, and you want to reduce. And speed being another MOE related to traffic, that's in tens. Drivers drive at 30, 40, 50 miles per hour, but the cost could be in thousands or 100,000. Again, because of that characteristic and that matter, you cannot simply add up and say, hey, whichever got the biggest number, that's the better one. So you need to come up with some formula, mathematical formula, to deal with that issue. And sometimes they have different scale. We have, like the previous example, all of them were in rates. One being, very bad, 5 being very good. All of them had same scale. But then, when we are talking about what if we wanted not data be subjective, even in that last example, and when we talked about experience, we use years of experience. Then years of experience, unit of measurement on that is first of all number of years, and scale is actual. It's continuous scale, it's interval. But then when it comes to presentation, scale could be subjective. How good the candidate made the presentation. So that has to be rate. So one scale for presentation could be rate. Years of experience could be in years. These are different scales being used. We cannot just simply add them up and say, whatever got the biggest number, that's the winner. And also different criteria have different weights. different clients, depending on the policies and the values, they have different weights. So in our formula somewhere we have to take into account the weights for each criteria. And another important matter, what is good, what is bad, how do we define that? Because at the end of the day we want to say which alternative is the best, which is the worst. How do you define best and worst? There must be some reference point. So these are all the complexities that we have to deal with, and ALTEVAL should take care of it. Okay, so this was part 1, and it covered the basics for alternative evaluation, and really it set the stage, and then in the next part I'd be showing a live demo of the actual ALTEVAL program and let you know how ALTEVAL deals with all those complexities and how it takes care of all those, all those things that we said it cannot be simply resolved and solved. So stay put for the next part.